Hello everyone, my name is Abhinav and today I will be talking about the transportation problem in linear programming. Now people in college will know what linear programming is. What is the graphical method, what is the simplex method, what are duals, you will know all of that. And for those who don't, I will be explaining about those in a later video. For those who do know, I'm going to be explaining to you the transportation problems. Now a transportation problem is when we have to minimize the total cost for transporting a product from a supply center to a demand center. Now what this means is that we are solving a given problem in a given table to find the minimum total cost to transport a product from a supply to a demand center. And how this is found is the minimum total cost, which is Z, will be equal to the summation I equal to 1 to m, j equal to 1 to m, both of which are summations Cij Xij. Here Cij is the given cost in a given problem, as we'll see later in the video, while Xij is the given cost in that particular column. And for the constraints, the summation of all of the allocated costs will be equal to the demand, while the given values on the bottom, as we can see over here, will be equal to the supply. And in this case, the Xij should be greater than or equal to 0 for all i's and j's, which means we should not have a situation where we have no matrix. Now, how do we find out if it exists or not? Well, if we are given a problem, we first have to set it up in this format, and we have to place all of these values, as we'll see later, at the bottom corner of the table. Here, the x part, which is xi, x11, x12, all the way up to xmn, will be the supply values, which are a1, a2, all the way up to an, which if we add up will give us ai. The same thing goes for the demand, which if we add up all of this will give us the value of bj. If both of them are equal, then we have a balanced transportation problem and we can solve. Now there are three given ways to solve this, of which I will explain one: the northwest corner method, the least cost method, and Vogel's approximation method. Today we will be understanding the northwest corner method. In later classes, I will be giving you explanations on least cost and Vogel's approximation method. Now in order to understand what is the northwest corner method, I have to give you an example. So over here, we are given a problem wherein the supplies are 19, 30, 50, 10, and the total supply over here is 7. For the second one, it's 70, 30, 40, 60, and the given supply is 9. And for S3, it is 48, 70, 20, and we are given 18. The demand for all of this, for this first column is 5, second column is 8, third column is 7, and fourth column is 14. What we have to find? We have to find the minimum cost using northwest corner method. So first, taking the northwest corner meaning, we have to take the value in S1D1, which in this case is 19. Now, we have to compare the supply and demand. For S1, supply is 7, for D1 is 5. Since 5 is less than 7, we allocate it over here as our C11. And for our value, and after allocating over here, we will be subtracting 5 from 7 and 5, for which we will get 2 and 0. Then we move over to the right one row. We move over to the right in one column, where we'll end up in S1D2, the number 30. Now we have 2 and 8, and since 2 is less than 8, we put 2 over here and subtract it from both these values. And so on and so forth, we move downwards and to the right, up and until we reach the last box, which is S3D4, where it's given as 20. Here we get 14 because both are equal, and in the previous column we had gotten 4. Since 18 was less than 4, we have to subtract 4 from 18 and allocate it at 70, which will be 14 and here 0. And since both of these are equal, allocate it over here and subtract it, and we get 0. If we get 0, then it is a proper non-degenerate basic feasible solution. If not, then we have to utilize one of the other methods to solve it. Here we utilize the allocation method, where we have to find out if the given number of allocations is equal to m plus n minus 1. While not given over here, m will be the rows and n will be the columns. Seeing that we have 6 in both of them. Here rows being 3 and columns being 4, we get 3 plus 4 minus 1, which is 6, and we have allocated 6 values as well. Now we go down to find out how we solve. We utilize the cost formula over here, and we allocate the values over here. In this case, the final answer will be rupees 1015. Whether this is feasible or not, I will be explaining about this later when we come up to the dependencies. But for now, that is all for today. Thank you so much for watching. If you like this, please make sure to like, share, comment, and subscribe. Also, sorry I have not been available for the last 2 months as I had my exams. But I assure you, I will be posting regular videos, and I will also be explaining some other concepts. Until then, stay safe, bye bye, and to all the people who have exams, all the best.